Okay, yeah, I think we're live now. So let's find out a little bit about KubeCon, and then we'll jump into this week's stream of Cloud Native Live.
It's more than just open source. It's about connecting with people. It's about being part of the community. It's about sharing what you know and helping others.
KubeCon is the best place to get hooked into the community and learn from everybody.
And let me tell you, people, this is just the beginning.
Cool. So welcome everyone to this week's episode of Cloud Native Live, where we dive into the code behind Cloud Native. I'm Bill Mulligan, and I work at CNCF. Every week, we bring you a new set of presenters to showcase how to work with cloud native technologies. They'll build things, they'll break things, and they'll answer your questions. So join us every Wednesday at 3 p.m. Eastern Time. And this week, we have Michael and Sharice, and they're here to talk to us about Kubestr. And also, just as and we talked about in the video, join us for the KubeCon Cloud Native Con Virtual EU May 4th to 7th to hear the latest from the Cloud Native community. And just to note, this is an official live stream of the CNCF, and as such, it's subject to the CNCF Code of Conduct. Please don't add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, just respect all your fellow participants and presenters. And with that, I'll hand it over to Michael and Sharice to kick off today's presentation.
Yeah, thanks, Bill. Yeah, so just a bit of a brief introduction. So I'm Michael Cade. I'm a senior global technologist here at Custom by Veeam. Yeah, excited to get into what Kubestr is and how it works. Suresh, why don't you introduce yourself?
Sure. I'm Suresh. I work at Custom by Veeam as well. I'm just a software engineer there. I'm glad to present Kubestr to you guys.
Yeah, I think a bit of an introduction to what Kubestr is a handy little tool that allows us to, well, identify, validate, and evaluate our Kubernetes storage. So taking those potential hard tasks, especially for the platform operators, the new guys to Kubernetes, taking that potential hard task, bringing that into an really easy tool or a handy set of tools, and running that against our Kubernetes storage, whether that's day zero or even existing clusters, and giving us some information or giving us some validation about that storage. So one of the key parts here is that it's going to identify the storage that you have available within your storage, and we'll get into what that demo looks like shortly. It's going to validate. In this particular instance, it's going to validate against the CSI driver is configured correctly, i.e. the snapshot functionality is up and running and working. And then from an evaluation point of view, it's going to enable us to benchmark your storage or this particular storage class against Flexible IO, so another open source project that enables us to get some benchmarking stats out of your storage. And yeah, why not? Let's jump into it, Suresh, and actually jump into a demo just to show everyone what it is and how it looks.
Sure thing. One second, let me share my screen. Let me know if you see my screen. Yep, too small.
Yeah, no, that's good.
So, I mean, kind of where Kubestr came about is, we've had customers, and the customers generally are like new to Kubernetes and have a tough time kind of figuring out their storage options. And so we kind of built this tool in-house and then realized that maybe there's a benefit to the community, and the community could actually use this tool and gather some insights onto their storage. So, I downloaded the tool here, Kubestr, and normally what somebody would do when they want to see what storage they have is they'd run something like kubectl get storage class, right? And it would tell you the storage classes that you have on your cluster. This is a DigitalOcean cluster, so it has one storage class, DO block storage, and this is the driver or the provisioner. but that doesn't tell you a whole lot. But if you ran Kubestr on this cluster instead, it does a little bit more. The first thing, it checks that you have a valid Kubernetes version, some RBAC check if the API layer is accessible. Some warnings here that come with the CSI drivers changing, because it's been rapidly changing in the recent year or two. And now we have more information about our driver, right? Initially, we just had a storage class, but now, we headline it with saying this is the provisioner that you have on the cluster. Points out that it's a CSI driver. It'll also tell you, some additional information about the driver itself, what kind of features it supports. And then it points out a storage class, which is what we saw earlier, but also that there's a volume snapshot class here, right? And once you have both of those, you should be able to take a volume snapshot and hopefully restore from that volume snapshot, right? So Kubestr, again, has those checks, or has the ability to validate whether your provisioner is set up to take snapshots correctly, right? DigitalOcean does a good job of, when you create a cluster, it sets up all of this infrastructure for you correctly, but for a lot of provisioners, it's not always straightforward to set up that kind of snapshotting capability. Many steps involved. You have to install many different types of objects, and then even after all that, you still may have some errors. And if you're new to Kubernetes, it's really hard to kind of debug these errors. So we thought this would be a handy tool to kind of validate that. So let's go ahead and run this check. CSI check. Just to look at the options that we have here. We do create. So in order to run this check, what are the things that you normally do? You create an application, which is a pod and a PVC. Then you take a snapshot of it, and so that creates a volume snapshot object, right? And then eventually you can restore using that volume snapshot object. So then, the cleanup flag lets you clean up those specific objects, and then you can always run in a different namespace that's not default. And then so the more required things are the storage class and the volume snapshot class. So let's run this check really quick.
And we also have a question in the chat from Carlos.
Sure.
Is there any application for this tool to back up etcd?
So this is not a backup. No, there isn't a backup functionality. It's not a backup tool. It's more of a tool to validate your storage, right? It's not necessarily a backup tool on its own. I hope that answers your question, Carlos.
Yeah, hopefully that's useful, Carlos. But I think this was another area where we thought, from a custom by Veeam point of view, or a custom point of view, is that by someone coming in that wasn't affiliated to the storage vendors and the storage market, it actually allows us to create something that is more universal across all storage arrays, but also public cloud storage. But this isn't really focused on the backup of anything. It just, like Suresh says, it validates that the CSI driver is configured correctly, and that's what we're going to get to and show that. But it's not a backup tool per se.
Okay, so maybe I have a question that might help the audience understand it a little bit more. Could you maybe explain why someone would need to benchmark their storage in their cloud?
Yeah, I can probably jump on that. Go on then, Suresh. You go.
No, you go ahead.
So I was going to say so benchmarking storage isn't a new thing, and it's definitely not a new thing for storage in general, whether it's cloud native today, whether it's cloud, whether it's virtualization, whether it's physical. Benchmarking our storage for particular workloads has always been a bit of a dark art and a challenge. And there's no reason why anyone today, in fact, that was the way to do this, is you would go and create your own application. You would create your own set of tools to be able to go and run this test. And I think what we've found is that it's a very manual process, and unless you know the depths of both Kubernetes and how you create a pod, you create a PVC, you create a persistent volume, you attach it, and then allow your application to run, then that becomes becomes even more of a challenge. I think the other element to that is that there's a lot of people coming into this space that are traditional platform operators, coming from a virtualization point of view, storage point of view, that maybe don't know Kubernetes to be able to spin up that pod and the PVC, etc. And this is just taking one of those tedious, potentially long-winded processes away and automating that process for you. I'll get into a little bit more about the challenges later on as well, in between Suresh's demo, around things like making sure that we choose the right storage, especially when you've got we've got so much choice. It's kind of overwhelming a little, in that you've got various different types of storage. And I think this also helps narrow down that choice. It's great to have that choice. We're not complaining about that. But being able to choose the right storage option for the workload that you need is important, and to do that as fast as possible, because ultimately, if you're, especially in the public cloud, you're paying for that storage, and if it's over provisioned, under provisioned, obviously you're not going to have the performance that you need. Over provisioned, well, you're definitely going to be paying more money or over the odds for that. So there's a few more challenges in there, and I'll get to them. But I think if we jump back into the demo, Suresh, then I think you're probably going to answer some of those as well. So,
yep.
And we'll get back to that.
So let's. Sorry, go ahead.
Sorry, there's also like 2 more questions in the chat. I don't know. We can also answer them as we're going if this is something you have coming up. So,
no, we can answer these. I see the one from Rajesh saying, "Are there any limitations?" There are not really any limitations. To do the CSI snapshot restore check, we obviously need a CSI driver. And then in terms of running the FIO check, as long as it's on Kubernetes and it's a Kubernetes provisioner, storage provisioner, then we should be able to run the FIO test against it. So yeah, there's no real limitations. It's just Kubernetes. It has to be Kubernetes, I guess. But yeah, what's the other question on here?
I don't know whether it's possible to connect SAN storage in an on-premise data center or object storage buckets from the public cloud to my Kubernetes cluster. Is this something this project could help with, or is that outside the scope?
This is outside the scope, but if you were able to connect a SAN storage to a Kubernetes cluster, then you would be able to validate its performance and whatnot using Kubestr, right? I won't help you actually connect it, but yeah, it can definitely help you validate that you're seeing the performance that you want.
Yeah, and I think it might have been a broader question from Deepak as well. Is it possible to connect an on-prem SAN storage in one location to a public cloud Kubernetes cluster, say in AWS or in Microsoft AKS or something along them lines? And I guess the answer is yes, if there's connectivity in place, right? So it can be done. There's some storage vendors out there that offer close to cloud type offerings, but yeah, this tool's not going to get that configuration for you. It's not, you're going to require that direct connect type situation, that connectivity. But what Kubestr can do is, well, validate that it's been configured correctly from a CSI point of view, and just give you the forefront that it is actually there and configured as a storage class within your cluster.
Cool. No, the questions keep on coming in like fast, so pretty popular today. Does Kubestr extend beyond the standard CSI benchmarking checks? Maybe something that is available like out of the box?
What do you mean by CSI benchmarking checks? Let's put it that way, because you're trying to benchmark. So the benchmarking that Kubestr does is like storage performance, right? It's a performance benchmarking. So whether it's CSI or a native entry provisioner, it's still all just storage, and we treat them all the same. But is there anything more specific, Suman, that you had about CSI benchmarking checks? I guess we can get back to that. But yeah, I mean, FIO is a test that we run.
Cool. And yeah, maybe you want to like dive back into the demo and it'll answer some of the questions that they have.
Of course. So yeah, let's like I said, where we left off was we wanted to run a check to see if you know, we can take a snapshot and restore from a snapshot. So that basically checking if this provisioner is set up correctly. And yeah, so you see that the first thing it is doing is creating an application to create a PVC, and it's creating a pod. And it's waiting for this pod to you know, become live. And then once it's live, it'll take a snapshot, and you should see a volume snapshot object getting created here. And like I said, these are not very, you know, if you're used to Kubernetes, they're not very complex things. These are things that Kubernetes operators do on a day-to-day basis, taking a snapshot, restoring their application. But if you're new to the landscape, it can seem like a bunch of different steps just to validate that you can take a snapshot correctly, right? So, you know, hopefully this creates that, you know, one command tool that creates an application, takes a snapshot, and restores it, and then validates, you know, that the data that was in the application originally is still there on a restore, right? So it kind of does that end-to-end workflow without, you know, all the various steps that it takes to do that. So yeah, so that's just the CSI check tool. We also have the FIO tool, right? And let's go ahead and run that on the same storage class, right? Again, creates a PVC, creates a pod. And I've seen this test take about maybe around like 40 seconds or so. So yeah, so the pod spun up, and essentially the application here is an FIO application, right? And we have a 100 gig PVC, and it's running this FIO test. And you know, the default FIO test that we have here, it does 4K random reads and writes, and then 128K random reads and writes. So it's actually 4 separate tests, and you will see the output in a second. So yeah, it shows you that it took around 30 seconds to run this test. The 4 different jobs that it ran, and you know, let's maybe keep note of these numbers somewhere here. Let's just say around, you know, 1900 read IOPS, 1300 write IOPS at 4K, right? You know, those seem like reasonable numbers. And you know, maybe you're like, hey, that's good enough for me. I'll go DigitalOcean for my application. But you know, maybe you want to try another cluster, right? And I have another cluster here. Let's see. I'm switching over to my GKE cluster. And now we can run Kubestr again here. Carlos, FIO sent for flexible IO tester. So again, this is, you know, it looks a lot like what we had in DigitalOcean. Shows you the Kubernetes version. Our back checks are okay. Aggregated API layers working correctly. But here I have 2 different provisioners. I have the CSI provisioner, and then I also have the in-tree provisioner. You'll see the CSI provisioner has a volume snapshot class. And you know, the in-tree provisioner doesn't have that kind of functionality, so you won't see that there. And you know, in this case, you know, we ran it on the CSI provisioner last, and let's run it on the in-tree provisioner this time. Run on SSD. Hopefully, it's the fastest storage option they have. Again, we can follow it along. It's creating a PVC, 100 gig PVC. It'll create the pod, and then it'll run the test. And I've seen this test run about a minute. in the past. I can answer some questions in the meantime, but let's see. Yeah, so it's starting to run the test.
Yeah, I guess one question that I have is, like, why would I benchmark my storage in the cloud? Like, what is this kind of information does it give me?
Sure. So like if you had an application, right, and maybe it's writing something to a database, right, storing maybe some records to a database, right. You want to know if your storage can handle the bandwidth of your application. Maybe you have thousands of users. Can it actually handle thousands of users writing data to your database at the same time, right? And that's something that you need to figure out what your I/O requirements are to your storage, and then you can how to figure out the right kind of storage to use for that, right? So maybe this will help you say, hey, I cannot use slow storage, like slow standard spinning disks. I need flash, like high-speed flash storage, and you maybe want to benchmark that. So that's a use case. That's a use case. I'm sure there's other use cases out there, but off the top of my head, that's one I can think of. Does that kind of answer your question?
Yeah, absolutely. I think it totally makes sense. You don't want to have something that doesn't work for your application and give a bad user experience. Seems like we have a couple more questions in the chat now too. So the first one is from Jay Warner. Could be a silly question. The benchmark function, is this optimize equals HDPM, but for the cloud?
I'm not sure what HDPM is. It's not necessarily going to optimize your storage at all. It's just to validate that your storage is fast enough for your application, or it's suitable for your application. Let's put it that way.
Yeah. So they said there's the Linux command HDPM. I don't know if you're familiar with that.
I'm not familiar with that, but FIO is also, I think. No, I don't have it. But no, it's actually simulating the FIO application. Here, maybe if I can post a link to FIO.
Yeah, if you just send it to me, I can post it on the screen.
Sure. Yeah, that's what I was gonna do.
Yeah, I think HDPalm is
So that's
more aligned to like Arch64 type frameworks, but it runs similar things, but gives back like information of disk. Does a varying amount of like spindle tests. It's not really the same. Maybe there's a bit of an overlap with FIO, so it could be seen as similar. But yeah, I think it's x64 or ARM64 only.
Yeah, cool. There's a couple more questions in the chat now. Is there a way to benchmark volume provisioning attachment with Kubestr? Maybe compare multiple CSI implementations from the same storage provider?
Yes. So, I mean, maybe if I understand the question correctly, you're saying, is there a way to run FIO with Kubestr, or check if the snapshot functionality is working? Because you can do both, and you can do them with multiple CSI providers. What are CSI providers you have in your cluster, right? So yeah, to answer your question, yes, it's possible.
Cool. And it looks like we also have an update from Joe about HDParm is more about getting the hardware parameters of the physical hard drive. So it looks like that's more on the hardware side, where Kubestr is more on like the software side. Is that right?
Yeah, Kubestr more on the software side. Yep. Joe, I'll take a look into HDParm and see if there's some sort of benefit that Kubestr can provide using HDParm, right? And that's part of it. Right? It's still kind of in its infancy, and we kind of want to see what other tools we could add to this little toolbox to make it a kind of a go-to for all storage needs in the cloud, right? A little toolbox.
Yeah, cool. There's another question. Can we simulate load testing using Kubestr?
If you have an FIO configuration that simulates a load test, you might be able to. Maybe I don't really understand the question, but I hope that answers it.
Yeah, and I can send a link. The link is here in the conversation if people are, looking for it.
There you go.
And I can drop it in the chat too.
It's a direct link to the FIO. So cool. If you want to get back to the demo really quick, you'll see here that we have, the IOPS that we're seeing here are nowhere near what, we experienced with DigitalOcean, right? And that doesn't mean that Google is worse by any means. It's just that maybe we haven't configured it correctly, right? And what you'll notice is that if you look at Google's storage, if you look at here, maybe I can post a link that'll tell you that. Yeah, here. Let's see. So, this is from Google, and it tells you how to, get the most performance out of your storage. And what they say is, if you use bigger volume sizes, you're going to see better IOs, right? So, our Kubestr test has the ability to. It has the ability to specify a size. So let's try. Our default's 100 gig. Let's try something bigger. Let's do 300, and then see kind of what that gives us instead of the 100 gig size. This one actually runs a little bit quicker than the previous one because, like I said, the bigger the volumes in Google, the better performance you're going to see.
Oh, cool.
This one takes about 40 seconds.
I think that's another thing to mention, Suresh, as well, right? Is that, okay, so this is going to be testing the blocks, the IO is testing against IOPS within the storage that's available to you within your Kubernetes storage. But also, so as Suresh just said, by changing the size of the persistent volume or persistent volume claim, that dictates what IOPS is available to you. But also think about the underlying node architecture, the compute nodes that you use, that can also dictate or change, depending on what cloud you're in, they change on what storage performance is unlocked. So Suresh has done an awesome CNCF blog on like, it's not a comparison, but it just goes to show that overwhelming choice that we have out there from a compute and storage point of view, and that no one's a winner in across the best performance, but it does show that there's so much options here, so many options here.
I just sent you the link. You posted it out there. It's a link to the blog, and I kind of, go through the same kind of test among like, the 4 different cloud providers, DigitalOcean, GKE, Azure, and AWS, and just kind of compare and contrast and kind of see how tweaking little things here and there between the different providers gives you, much different like end results, right? And like it's hard for you to, if you're just jumping in, to make that decision of which one to choose without having a tool like this that can quickly, run some sort of a test and get you some metrics that mean something to your application, right? Oops.
Yeah, and
so let's see. So, there you go.
So it seems like there's a question from a user on LinkedIn. What are the best storage backup third-party solutions for AKS and Azure? And it seems like you could use Kubestr to help figure out like exactly what your application parameters are and like which storage is best to meet the needs of that application. Is that right?
Yep, precisely. So like I said, it's hard to say what is the best storage without knowing what your application is, right? And so it really depends on your application and your budget, and then you can pick what storage works for you. No, Deepak, I'm not writing 300 gigs of dummy data. It's a 300 gig volume, and I think I think the file sizes here are 2 gigs. So it's 2 gigs of dummy data and a 300 gig volume. But the size of the volume itself dictates the kind of performance you're going to get, at least with Google, right?
Yeah, that's a good point though as well. And out of the box, Kubestr uses so the default FIO test is a random read and random write at 4K block size, as well as 128K block size. But there's a huge library repository of FIO configuration files that you can kind of bring to test as well. So Suresh there showing what that FIO configuration file is. So if you know that your workload works in a 8K block size, or you need to walk back the file system or in a reverse manner, you know that it's a sequential write. All of these changes could be modified in your own FIO configuration file, so you can run that against the storage as well.
Yep. Let's see. So we want to run it against our same SSD storage class. Let's make it the same 300 gig volume so it's fast. And then let's see, I think it was -F. And then basic verify. Let's see. Oops. So yeah, I mean, you don't have to use our default test. Really, it comes down to your application, right? So if you kind of know your application's FIO need, signature, or what that looks like, what your load looks like in terms of an FIO file, you can pass in that FIO configuration here, and then we'll run that particular FIO test. So it's running this particular test on that storage class on a PVC of size 300 gigs. Let's see, I think this one takes about 30 seconds or so. So what else? We can also, write all this output to out as a JSON. So if for some reason you want to do scripting where you wanted to run multiple FIO tests or whatever your needs are, you could easily, get this output back as a parsable JSON file, and then, maybe collect some data that way. Or if you're trying to make some pretty graphs or something like that to kind of showcase something about your data, then that's what you can do. So yeah, this is a different IO pattern, and you're seeing much more different results, right? But like I said, it really comes down to what your application is, and if you figure out what your application needs are, then this tool can be very helpful.
Yeah, we just posted some of those examples for FIO as well, that you can run on there. I was going to cover some of the. Okay. So there's another question. Do you plan to have a CRD and a controller for Kubestr so that it runs directly into the K8s cluster and is declarative?
Yeah, there were plans of that initially. For now, this is, like I said, it's in its infancy, and it's what it is right now. It's just a executable, but yeah, down the line we could make it a CRD, CRD based, operation. Yeah, these are all kind of things that we have in our pipeline. We also kind of wanted to make this more of a community based tool. So we really wanted to get people kind of pitching in, running their own FIO tests and telling us what their results are. So maybe like a leaderboard or something where other people can go and get a better understanding of how other people's storage is performing, right? We kind of we're hoping to kind of move in that direction where we have more of a community involvement with it, community participation. But yeah, like I said, right now it's in its infancy. We just want to see if it's actually useful for people before we take that next leap and do some cooler stuff with it.
Yeah, so maybe if people want to get involved, how can they do that, or how can they try it out or test it out?
I'd suggest start off going to Kubestr.io, installing it and running it. And yeah, we also, again, we're open source, so go to our GitHub page. There's links on that for that on their website as well. And yeah, fork the repo. Feel free to make some changes. Yeah, visit us at GitHub as well.
And maybe
Go ahead.
can you tell us a little bit about like the roadmap or where you see like the project going?
Sure. Like I said, the first few things are additional tests that may be useful, right? There's some people want to be able to benchmark their object storage. So that was something that I was looking into. This is persistent storage. It's not the same as object storage. So, maybe we could kind of foray into that, venture into that a little bit. But yeah, like I said, the other bigger thing is to make this a more community-driven project. Have, like I said, some sort of a leaderboard or some sort of a place where people can come, because you don't want to run the same test 100 times, 100 different people running the same test 100 times. If you can just go look, saying, hey, I have that exact type of infrastructure, I can see what kind of results I'm going to see. It makes that decision-making process easier, right? Obviously, we'd like to get more involvement from some of the bigger storage vendors. Maybe have them write specific FIO tests, like that say, hey, if you're looking for a certain type of application, this is an FIO test that would benefit you, then you should run this particular test, for example. So yeah, I mean, there's a couple different ways that we've been trying to, a couple different options on our roadmap. Like I said, we're still kind of seeing what's the most important need right now, and then moving on from there.
Yeah, I'd just add to that point as well, Suresh, around the so we mentioned storage providers, storage vendors. That obviously makes sense, but also like database vendors as well. Like if they have they're going to have a better understanding of what their database looks like at load. Obviously, that's not going to reflect on every single individual customer of theirs, but if we can team up with database vendors, storage vendors, and get a much wider view of what that application or what that database requirements look like, and you start putting FIO specific tests around that to understand what that looks like, and then have a library of these results, I think that becomes very useful. And I've been calling it over the last week that this has been released, this is really that easy button to understanding your Kubernetes storage. Really is. So as Suresh kind of very easily went through, it's a super simple way of being able to test against your storage, but it's a lot quicker than having to manually go and create pods, create PVCs, create PVs, then understanding actually how the application is going to run against those. This is literally download to your Mac OS, to your Linux box, to your Windows box from GitHub, and get going. That's as simple as that. And then, yeah, to go back to the roadmap point, the other thing would be nice, I think, around that leaderboard would be something around like how do we visualize? How do we make that output, that CLI output? How do we visualize that? How do we put that into some sort of visualization so that we can compare and see it much easier than having to scroll through endless command line type text?
And yeah, there to that point, there was, right now I just give you the FIO results, right? Like maybe down the line we could do some more analysis on the FIO results, right? Say that, hey, tell the customer or tell the user what is impacting their performance, and maybe you have a bottleneck, because of the storage size or something like that, right? So I mean, that requires a little bit more understanding of the storage and the results of the FIO test itself. But down the line, we could see ourselves giving you a more descriptive output than just these are your FIO results.
Cool, and it looks like there's actually people trying it out right now as we're on this. So I got this error message when Kubestr pulled the image, failed to pull image, user cannot be authenticated with the token provided. Do you have a quick way to allow Kubestr to pull the image? It's a live debugging.
Yeah. I wonder what image it's struggling to pull, because Kubestr, I believe the images that are all publicly available, I think they're Docker Hub. User cannot be authenticated with the token provided. It's kind of hard to tell without a little more details. Boonchu at Twitch, do you want to, maybe add some more details to our GitHub, create a GitHub issue and add some more details there, and I'll help you debug that in time.
Yeah, definitely.
Yeah.
And it's cool to see people are actually trying it out, like as we're live right now.
I know. Yeah. It is pretty cool.
Cool. Yeah. So I think if you create that issue on GitHub, you'd be happy to help you out. And then I guess going back to like the leaderboard a little bit, just checking if you see like any fluctuations in regard to the IOPS over time from different cloud providers. So if we do benchmarking and like have like a leaderboard, would it change over time? Would it continually like update? What have you seen so far?
Well, like I said, right now we don't have enough data to see if there's been any like trends, but I'm sure if like the cloud providers, I mean, they have so many different offerings, right? Like it's not always like that, like, hey, I have one type of storage and one type of node. They have nodes optimized for storage, or they have faster storage, slower storage. So yeah, you will see them, like the cloud providers, offering faster or better storage options as they progress as well. So yeah, you'll definitely see fluctuation in what cloud providers offer. Right, they're trying to be competitive amongst each other as well. Right.
I just posted the Slack as well. It could be a good area to start that debugging process, Suresh, as well. The other thing I was going to mention was around obviously CSI, especially in the public cloud. I've been playing a lot around that. I think, Suresh, you mentioned it, like DigitalOcean out of the box is CSI first. They deploy with CSI. You don't have any in-tree provisioner, which we know is going to become the norm. I think it's the next version of Kubernetes, maybe even the next one, but it's very much CSI first as we move forward, and it potentially won't take that configuration route, or I would say the pain points as a newbie to this world is the CSI driver implementation. Having to install the driver is a little bit of a challenge at the moment. It's a manual task at the moment, so clearly I'm the error there. But there's a task that you have to go through, and I found that Kubester's a really good kind of full stop to understanding whether there's something wrong. So in Suresh's demo, he shows you all the good stuff that it says okay, that the CSI snapshot was successful and he could restore back to a clone. I've seen many more of the errors that come with that, where the snapshot wasn't successful. And it's just really, really short, sharp, to the point. Let me know what it is, and then we go and troubleshoot that. And it's generally going to be down to probably your IAM or your secret credentials that at least in AWS, and again, probably user error. But I think that as we're in that transition period of CSI becoming the norm, this is going to be an awesome tool moving forward. And it's not just for that day zero cluster rollout. It's going to be kind of to the last question around, do we see IOPS fluctuating? Well, this is something that we should keep checking, because at the end of the day, you're paying for that service, that storage on the cloud provider. You keep using Kubestr to validate that you're getting the resource that you should be getting, right?
Yeah, definitely. Is there anything else you two want to show today?
I was going to kind of show the same thing. I've got an AWS cluster that I could jump in, but it's going to be very much the same stuff that Suresh has shown. So I don't know if we need to go in there. I think the other thing, again, Suresh might have touched on it, is around, so as long as you've got kubectl access to your cluster, that's where Kubestr will run. It will use the kubectl context to run these tests in. So if you don't have kubectl, Kubester's not going to work. also, if you've got many different contexts like Cerise showed, is you're going to have to jump manually between those before you can run Kubestr against the other clusters. But yeah, I think I was just going to show Kubestr.io as the first resource, because on there is a very brief description, kind of what we touched on at the very beginning around identifying, validating, and evaluating your Kubernetes storage and hitting the easy button, and kind of touching on that CSI challenge that I just touched on. Then a short demo from Suresh on how to use it, and then some steps on where to grab the source files so you can install it on the OS that you want to run it on, and then a few brief instructions on how to get started and run that. Then I've also shared around the flexible IO, the configuration, like the ready-made community-driven FIO configurations. Yeah, I think there'd be, and then also the Slack that we've just started, so it's very fresh in there. This has only been rolling out like since the 1st of April, so it's really new, and yeah, looking forward to the feedback from the community and driving what this could be. I think, yeah, it'll be fun. Anything you'd add, Suresh, at all?
No, I think you covered most of it. Yeah, like you said, I'm excited to put it out there. Excited to have people actually using it, and really hope it benefits people, and they can see its value and eventually contribute to it, right? So yeah, I'm looking forward to that.
Yeah,
I can't.
Bill, I think you're on mute.
Yeah.
Like classic, like we've been doing this for like a year now.
Enough.
Yeah, clearly I got to go back to purgatory. Like, okay, like one more round of lockdown just so you can figure out mutes again. Okay, with that, thanks everyone for joining the latest episode of Cloud Native Live. It was super great to have both Michael and Cherise with us to talk about Kubestr. I'm really excited to see how this project grows and the community that comes up around it, and really seeing like those benchmarks, so we can track storage performance over time and see if what you pay for is what you actually get. I also really loved all the interaction that we had from the audience. I think this is really tons of questions coming out. Super excited to see that. Even like people trying it live, like as the session is going, like super fun to see that interaction. And yeah, looking forward to see the audience again. Just a reminder, we bring you every single week the latest cloud native code every Wednesday at 3 p.m. Eastern. Yeah, and if you haven't gotten your ticket yet for KubeCon, then there's a code for you to do it. So yeah, see you around the cloud native community. Thanks.